بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضة لغات، أهلا بكم. اليوم سنتطرق إلى درس جديد في مادة الاستاتيكا وهو الاتزان. Welcome my dear student in our program in second 3. Today we are taking new lesson in static is called equilibrium. My dear student, look at the first example about equilibrium. My dear student, what is the equilibrium? If we have AB is a rod of length 90 centimeters and its weight 50 Newton, act at its midpoint, rest in horizontal position of two supports. One of them is at the end A and the other is at a point 20 centimeters from B and carries a weight of magnitude 20 Newton at a point 15 centimeter from B. Find magnitude of the pressure on the or on each support. Find the magnitude of the pressure on each support. Also find the magnitude of weight that should be suspended from the end B so that the rod is about to rotate. My dear student, the required magnitude of the pressure. What is the pressure on each support? Each support has pressure P1, P2. Also, find the magnitude of the weight that should be suspended from the end B so that the rod is about to rotate. Look at, my dear student. What is the magnitude of the pressure on support at this instant? Look at the solution. My dear student, we have AB is a rod. Look at, my dear student, what is the magnitude of forces or weight? We have 50 Newton, 20 Newton. We have to support at A and B and C, at A and C. Support at A, its action or pressure P1. Support at C, its pressure P2. Look at, my dear student, 20 from 15 centimeter from B and 15 centimeter from C, 50 Newton from 15 centimeter from C and 45 centimeter from A. My dear student, what is the length of AB? Length of AB, it's sum 45 plus 15 plus 15 plus 50 equals 100 centimeter. But 100 centimeter, we have two weight 50 and 20 Newton. Act this weight from A, 50 from A as 45 centimeter, 20 Newton from B at 15 centimeter. We have to support at B1, B2, act at A and C points. The resultant, my dear student, in this case, B1 plus B2 equals sum 50 plus 20 equal what? Equal 70. This is the first equation. Look at moment about A equals 0. What is the moment about A? We have four forces, B1, B2, 50, and 20. But B1 in this case equals 0. Why? Because moment about A, this P1 is the force act at the point A. And we know that if the force act at this point or passes through the point, this is the moment of this force about this point equals 0. Then we have three forces, B2, 20, and 50. Look at, My dear student, we have two forces, 50 and 20, two weights or two forces. Its direction by using clockwise and anti-clockwise about the point A, the two forces 50 and 20 clockwise, but B2 anti-clockwise. Remember, my dear student, the force, if the force in direction clockwise is negative, anti-clockwise is positive. Therefore, B2 times length 45 plus 15, 60 equals 50 times 45 plus 20 times 75. In this equation, find the value of the pressure B2, which act at point C. Then divided by 10. Therefore, B2 equals 3,750 over 60 equals 62.5 Newton. This is B2. By substitution about first equation, B1 equals 7.5 Newton. Look at, my dear student, the weight B at B is W. Moment about C equals 0. Therefore, my dear student, 50 about C. Look at about C. We have 5 forces, but 5 forces at C, B equals 0. Moment about C respect to the force B equals 0. Then we have the force 50 and 20, W, B dash. Therefore, 50 times 15 equals 20 times 15 plus W times 30. Therefore, 750 minus 300 equals 30 W. Therefore, my dear student, W equals 15 Newton. Then B dash plus B equals 50 plus 20 plus 15. Therefore, by using substitution, B dash equals 85 Newton. Now we are translate to another example. AB is a non-uniform rod of length 5 cm. Its weight of magnitude 2 Newton is fixed at the end of B, and weight 7 Newton is suspended at the end A. My dear student, we have AB is non-uniform rod. What do you mean of non-uniform rod? If AB is uniform rod, its weight act at midpoint. My dear student, if the rod is uniform rod, what do you mean of uniform rod? Its weight act at midpoint. If we have AB, its length 10 cm, then its weight W act at midpoint of AB, or from 50 cm from A or 50 cm from B. But AB is non-uniform rod, means its weight don't act at midpoint. Remember, my dear student, uniform rod, its weight act at midpoint of this rod. Uniform rod, its weight act at midpoint, but non or ununiform rod, its weight doesn't act at midpoint. My dear student, we follow the important example. AB uniform rod, non-uniform rod of length 5 centimeter, if weight of magnitude 2 Newton is fixed at the end B, and weight 7 Newton is suspended at the end A. The rod is in an equilibrium horizontally at a point of distance 20 centimeter from A. If the weight at A is decreased to become 4.2 Newton, then the rod will be in equilibrium horizontally at a point of a distance 25 centimeter. What is required? Find the weight of the rod and the distance between the point of weight application and the end B. Look at the solution. My dear student, we have a B rod. Look at weight 7 at A, support at C, weight W at E, weight of 2 Newton at B. AC 20 centimeter. Let EC equal X. Then BE 45 minus X. My dear student, look at, we have weight 7 act at A, weight 2 at B, W, its symbol of its weight of the rod AB, act at E, suppose a distance X from C, support at C, its reaction R1 or pressure R1. Look at BC 45 centimeter. We let EC X. Therefore, BE equal 45 minus X. Moment about C equal 0. We find moment about C. Moment about C equals 0 by using 2 times 45 distance between B and C equals W times X minus 7 times 20 equals 0. Therefore, W X 140 minus 90 equals 50. This is equation number 1. Equation number 2, we find moment about D also equals 0. Therefore, we deduce the second equation. Second equation, 80 plus Wx minus 5W negative 105 equals 0. Therefore, 80 plus 50 negative 105 equal 5W. By using Wx equal 50. Therefore, find the value of weight of the rod equal 5 Newton. Then we deduce the weight of uniform rod AB equals 5 Newton by using two equations. The first equation, moment about C, second equation, moment about D. And we deduce that two equations about X and W. By substitution, we find the value of weight of the rod AB equal 5 Newton. From equation 1, by substitution, Wx equal 50, find the value of X equals 50 over 10 equal 5 centimeter. Therefore, W equals 5 Newton. Act as a distance AE equals 25 plus 5 equals 30 centimeter from the end A. My dear student, now we are translate to another example. AB non-uniform rod, length 100 centimeter and weight 60 kilometer width, is suspended from its middle by vertical string, and when a weight of 30 kilogram weight is suspended from one of its end, what do you deduce? Remember, my dear student, we have AB non-uniform rod, length 100 centimeter, its weight 60 kilometer weight, and is suspended from its middle by vertical string, and when a weight of 30 kilogram weight is suspended from one of its ends, the rod is in equilibrium in horizontal position. What is required? Find the vertical force which acting at the other end after rising the weight. The rod remains in equilibrium in horizontal position. Look at the solution. My dear student, look at in the opposite figure, we have moment about D equals 0. Remember, T is a tension of string in middle of AB. AB equals 100. Therefore, AD equals 50 centimeter. DB equals also 50. But we let DC equals X. Therefore, BC equals 50 minus X. We have to wait. Look at, my dear student. We have weight 30 act at A as a distance for 50 centimeter from D. And we have weight 60 Newton. Act at point C as X centimeter from D. Tension T1 is string from the middle of AB. Remember, AB equals 100 centimeter. Since, my dear student, moment about D equals 0, by using equation of equilibrium, 30 times 50 equals 60 times X. What is the value of X? X, and student, 30 times 50 divided 60 equals what? 25 centimeter. Then X equals 25. Therefore, we deduce that C as 25 from D and 25 from B. C midpoint of DB. Therefore, AC equals what? 50 plus 25 equals 75 centimeter. Look at, my dear student, if we have second force F act at point B, and the distance between B and C equals 25, distance between C and D equals also 25, then what is the moment about D? By using moment about D equals 0, the same method, F times 50 equals negative 60 times 25 equals 0. Find the value of F. F equals 30 kilogram weight. My dear student, now we are translate to another example. AB is non-uniform rod, length 9 centimeter and its weight 30 Newton. Act at a point 40 centimeter distant from A. It rests horizontally on two supports at the point C and B, where AC equals 10 centimeter. It carries weight magnitude 10 Newton at point 30 centimeter distant from B. Determine point on the rod at which weight magnitude 29 Newton should be suspended to make the magnitude of the reaction at C twice that at B. Remember, determine, my dear student, determine a point on the rod at which a weight magnitude 20 Newton should be suspended to make the magnitude of reaction at C twice that at B. Okay, add the solution. My dear student, look at a rod AB, suspended B R, weight 10, weight 3, 30, suspended 2R twice at B, 2R suspended or support at C, twice support at B, suspended at B and C. Support at C, twice support at B. Then if support at B R, support at C to R. Distance between A and C 10 centimeter, and between midpoint and C 30 centimeter. Look at, we suppose length is X, 20, act as X from B by using equation of equilibrium 2R plus R equals what? 30 plus 10 plus 20. Therefore, 3R equals 60, R equals 20 Newton. Therefore, my dear student, moment about B equals 0 to find the value of X. 20 times X, the value of R is 20. 20 times X plus 10 times 30 plus 30 times 50 minus 2R times 80 equals 0. Why 2R with negative? Because, my dear student, moment about D, look at the direction. 2R opposite direction of three forces, 10, 30, and 20. 10, 20, and 30 in anti-clockwise with positive. But support at C, its magnitude 2R in clockwise with negative. In this example, we find the value of X. 2X equals 2R times 8 minus 30, negative 150. Therefore, by substitution, R equals 20. Find the value of X. 2X equals 140. Therefore, X equals 70 centimeter. From the end B, the value of X equals 70 centimeter from B. Weight is suspended at a distance 20 centimeter from the end of A. Dear student, by the end of the lesson, we know that equilibrium lesson is very important lesson. Why? We have two types of the rod, uniform rod and non-uniform rod. Uniform rod means its weight acts at midpoint. In this case, we have two equations of two equilibrium. The first equation, we must the weight which act at the rod under the rod equals up the rod. The second equation, we must find moment about any point. We have two equations From the two equations, find the value of two unknown. And we know that if we have rod is non-uniform, what you mean? We mean that its weight don't act at midpoint, at any point from A, from B. If we have AB as example 10 centimeter, if AB uniform rod, then its weight act at 5 centimeter from A or from B. In this case, we find the two equations to find the unknown required. My dear student, by the end of the lesson, I am very happy to spend such time with you. Don't forget, math simple, think, work, deduce. Thank you. Goodbye.